One more time. These are the more basic of the trig function stylings, the ones that involve just a triangle and some missing components, not the more advanced ones where we have a missing triangle and missing components. These are simpler ones. You may use any trig function at any point in time for any of these problems, but only certain trig functions are actually all that useful. The big three, sine, cosine, and tangent. Those are all nice because they're calculator based. We can do them very easily. The other three, not as nice, still true, still useful in their own ways, but because the calculator is assisting us with a lot of this, not all that helpful. And of those main three, sine, cosine, and tangent, many of those three, usually at least one of them, will not be useful at all because of how the picture is designed. So let's take a look at our first example problem. I build myself a triangle. I throw a random number in the corner. Let's call it 32 degrees. And I give one of the sides a number value. Let's call it 6. X, Y. And I tell you in the instructions, find both missing sides. Now, if you have a single missing side, as we discussed last time, Pythagorean theorem is really hard. For this type of triangle, we can use the trig ratios along with this known trig angle, the 32 degrees, that set up the three basic trig functions so we can try to solve for something. Now, that being said, I will set up all three just to show you. You should prioritize the ones that contain one variable, because those are the ones that are actually solvable. The ones that contain two variables, not very good. Let's start here. I have 32 degrees. Let's talk sine of 32, cosine of 32, and tangent of 32. Now, in this picture, based on how this is constructed, I can use the definitions of sine, cosine, and tangent in terms of opposites, adjacent, and hypotenuse to determine the three trig ratios. Example, sine of 32 would be the opposite side, 6, over the hypotenuse, y. Cosine of 32 would be the adjacent, x, over the hypotenuse, y. Tangent of 32 would be the opposite, 6, over the adjacent, x. And like I said, I could do the other three that we did last time. Those are only useful to define, not necessarily to do for any individual problem. Because I have sine of 32, sine of 32 can be plugged into a calculator. Cosine of 32 can be plugged into a calculator. Tangent of 32 can be plugged into a calculator without any special tricks or rules or anything. Whereas I want to use cosecant, I gotta use an inverse property to get the answer, which is more work. If I want to find cotangent, inverse property has to do it for the calculator to even get close. So, these three trig functions are all three true based upon the definition of the picture provided. However, of these three, one of them, bad. The cosine one, because it contains two variables. That doesn't mean it's not true. It doesn't mean it doesn't work. It wouldn't simplify the correct answer if I knew what x and y were. The problem is I don't know what x and y are. So while cosine of 32 is a number, I'll have a number is equal to two variables. I can't solve that by traditional algebra. But for now, I'm going to put cosine on the back burner and cross it out. The other two are much more straightforward. They contain one variable and two numbers. Yes, two numbers. Sine of 32 is a number value the calculator will determine. 6, number value. The calculator doesn't need to calculate that. It's 6. With a single variable. So let's solve these two. I take this first equation. Sine of 32 is equal to 6 over y. Now, there are two approaches we talked about in class to doing this. You can do it without the calculator for the majority of it, meaning you leave sine in the problem for as long as possible. This tends to give the most accurate answer possible, and in many cases is actually pretty easy because you're not dealing with this nasty decimal, this nasty fraction in there the whole time. However, some people are not a fan. They want to jump straight to calculator mode. That's fine. I'm going to start by doing it without a calculator. Here we go. I want to get y by itself. Y is permanently in the denominator. Step 1. Multiply both sides by y. This will get it out of the denominator and give me y times the number sine of 32 equals 6. If I want to get y by itself, I can add, subtract, multiply, or divide. Since I am multiplying by something, I can divide to get rid of it. I divide both sides by sine of 32. On the left-hand side, I end up with y by itself. On the right-hand side, 6 over sine of 32. This is the most accurate answer you can give. It is the best answer. However, many problems ask you to give it to a decimal place, usually 3. So, there comes the calculator. If I would please, Ebony, I see a calculator in your hand. You're my subject. What is 6 divided by sine of 32? Fantastic. That is also why. Both these answers are acceptable. Unless it says, give a decimal answer. If it says give an exact answer, the top one is your go. If it says give an exact answer, it's the top one. If it says gives an approximate answer or a decimal version, it's the bottom one. So approximate or decimal, it's the bottom one. 11.322? Yes, 11.322. 11,322? I can see it. So, this next one, I will jump straight to the calculator from the beginning. It doesn't change the process or the results. It just means you're dealing with a nastier number along the way, which is fine. Like, some people would rather deal with a nasty number than deal with a trig function. Remember, sine of 32 is a number. Like the square root of 17, it's a number. You can add it, you can subtract it, you can multiply it, you can divide it. Sine of 32 is one number. Now, cosine. Now that I have y, I can actually use cosine. Because it's got cosine of 32, that's a number, equals x, which is unknown, divided by y, which is now a number. I could use cosine at this point. Or I can use tangent at this point. Because tangent is already set up. Remember, sine of 32 is a number, 6 is a number, x is an unknown. I have one variable, two numbers, I could solve this. Or, final option, because I now know two of the sides, I can use Pythagorean theorem to find x. In theory, all of these should give me the exact same solution. In fact, I'll showcase both very quickly. Here we go. I'll start using this bottom formula for tangent. I'm going to solve for x, just like I did for the other one. Here we go. Multiply both sides by x. I get x tangent of 32 equals 6. Divide both sides by tangent of 32, because remember tangent of 32 is a number. I get x equals 6 over tangent of 32.
I did it like this.
What number did you get, Cole?
I got 9.601. I got a 02.
Oh, that's just the difference between rounding errors. 9601, did you do it by using Pythagorean theorem?
Yes, I did that.
And you got?
I did it like we did the first one.
Okay, so this is the small difference between using an approximation, 11.322, and the actual number, the tangent. He got one decimal place off, 3 decimals down, so that's a 1,000,000?
Yeah.
1,000 off for an approximate answer. That's pretty darn good. Okay. If you ask me which one's right, I will tell you the trade secret of all math teachers. I ask you for 3 decimal places because I only grade 2. This way, if you mess up the last one because of a rounding error or something, the first 2 are still right. It's a little trick we use. It's terrible, it's mean, it's cruel. It guarantees you get more answers right. And again, his point, was it 602 versus 0.601, they're the same answer, according to the math. If they did all the math correctly, I shouldn't take one off or the other. So again, I would usually ask for more decimal places than you actually need, specifically because I want to make sure you get at least the minimum right. So, got it. Levi, do it this method, 9.601. Cole, do it the other method, 9.602. Same answer to me. The joke my grandfather always used to say, it's good enough for government work. So, these kind of problems. Well, it's this straightforward, much simpler than the more advanced ones where we have a missing side that's an unknown value. But again, these ones are also worth practicing. These ones are pretty standard from geometry. We did a lot of these in geometry back when I taught it, and I know many of you guys did when you guys learned it last year or 2 years ago. So, that being said, I want to give plenty of time for some homework problems. I'm going to put 4 homework problems on the board. About to do a short assignment for a Friday. Let's put these 4 up here. Give some random numbers. Let's see what happens. These 4. If you get them done before you leave, you may turn them in along with the bell work. For this bell work, make sure, put them on the same page. Don't waste too much paper for me, okay? Put the bell work and homework on the same page. And make sure if you haven't gotten that homework assignment from yesterday finished, it needs to be turned in, so prioritize that one first.
Same page.
4 problems. 1, 2, 3.
Oh, fair
4.
4 this time.
Actually, I'm doing 4 when I said I would do 4. Not 9 when I said I would do it. Right.
Or you mean, yeah.
No.
No. There were still 8. You just.
Okay, I like that triangle. The weirdest part about these ones is you can have some wonky looking triangle things going on here.
You don't have to do that.
It's gonna curve it.
But I got it.
You don't.
I got
I got hat hair going on right now.
That is.
What? Could you not just draw them all the same?
Nope. Alright, let's see.
Has Garrett done any of his homework?
68 degrees.
Douglas?
What?
Has Garrett done any of his homework?
39 degrees.
He's done the quiz.
The quiz, that's on, I know.
I don't ever draw triangles like you. I have to do them the same way.
Hey, respect. I try to as often as I can.
Who does this?
Yes, ma'am.
Scott emailed you the picture of his helmet.
Thank you, Scott.
Scott's just a good guy. No.
Yeah.
Like, half of us are like actually going to and having like me, like the girl right next to me had corona and I was quarantined.
I'm not quarantined.
Coronavirus.
His classmate got corona and he got quarantined at home. I'm like, what?
But I think it's because maybe that's his parents were all like, we don't want to go to school to talk to people. This one I feel like was quarantined for a while.
Scott, one.
He was at lunch.
Yeah.
So. That makes sense.
But it really don't because you're only there for.
Yeah, but you're eating right next to each other without your mask on.
I mean, I think
Yeah, I know what you
even
mean.
if they are wearing masks, they can still get quarantined. Yeah.
What you gonna do? Within 6 weeks.
Alright.
4 inches. Yep. Alright. Got the rest of the block to work on those 4. Again, make sure the homework from yesterday gets included. Those 8 problems.
Oh.
Definitely 8. 100% 8. Sorry, Bob. There we go. Give up 2 minutes.
Never mind.
Okay,